All right, some extra decoration because there wasn't enough, so I brought a little bit. This is about Algolia and Magento 2. Who knows Magento? Some hands. It's an e-commerce framework written in PHP, but it's fine now. It's fine now. Oh, wait, it's zoomed in a bit. Oh, wait. Now we go. I have to scroll. Sorry. Can we do this better? Wait. Yeah, okay. This is easier. So it's a little bit smaller. Mooi. That's our local hi from Groningen in the Netherlands, where we're from. It also translates to I in French, so that was funny. I'm Peter. I run Elgentos with 12 of my colleagues, of which one of them is Guido. He's sitting there. We built this thingy. I did the back-end part. Guido did the front-end part. So I'll also explain about the front-end part, but questions for front-end will be directed to Guido. Case study. It's about our client, All for Honda. We're building a part finder. So what does All for Honda do? They sell car parts for Hondas, for Honda cars, like this one. Guys who tune it, they need a lot of parts to tune it because apparently they're not good when they come from the factory. So they have a lot of tuning parts. One of the problems is a lot of products. They have about 16,000 products all in their warehouse. And that's a lot of products to know which product will fit on what Honda. The second problem is that they have a lot of suppliers. This is just a part of them. They have about 150 to 200 suppliers, mainly Japanese suppliers, who apparently have no idea on which of these cars their products fit. So you have an exhaust. Yeah, here's an exhaust. Oh, does it fit on a CRX? I don't know. Does it fit on an Acura? I don't know. So that's a problem. But it was all in their heads. So the guys at All for Honda asked us to come up with a solution to make this data in their head presentable to their clients who want to buy auto parts on their web shop. So our solution was based on Magento with Laravel and Algolia. Sorry, again, PHP, but yeah. So this is what we built in Laravel. This is the part finder tool, in which on the left side you'll see a list of product parts that are in Magento that are pushed to the Laravel application. On the right side you'll see a list of cars on which the parts will probably or maybe or definitely fit. So the guys at All for Honda, they have that all in their head apparently, and they know exactly, oh, this is a start motor for a Civic Del Sol, and it will fit on a Civic Del Sol from 1999 to 2001, but not the 2.0, but the 2.1 liter engine version. So we tried to, a little bit back, we tried to build a tool so they could make their knowledge explicit from in their head to a database. So their data flow went from this, is now this. You put in a basic product data into the web shop, which is run on Magento. Then we push it through the API to the part finder, which is built in Laravel. Then we enrich the data, so make implicit knowledge explicit. We put that in Algolia. And then the Magento extension, Magento will take that data from Algolia and show it on the front end. We do pushing from Magento to Algolia. The heavy work is done for us with the Algolia Search Magento 2 extension for Magento 2, which is written by Jan Petter. I think he isn't here right now, but he's our hero. It's a great extension. The magic sauce in this thing is called hooks. So the Magento 2 extension written by Jan Petter has a few hooks. So they have front-end hooks and back-end hooks. And the front-end hook is the Algolia, which we use, by the way. There are multiple, but we use these two. The front-end hook is the Algolia hook after instant search start. So it's a lot of type. And the back-end one is the Algolia after create product object. So how do we use these? This is in Magento. This is an event. Magento is event-driven. So this is an event in Magento that is called when a product is saved. And it will run an observer, and that will take the information from the part finder Laravel tool, append it to the product object within Magento, and then push it to Algolia. So our first implementation structure for the data type was like this. So we had a make, which is always Honda, so only one. Then we had a model, which is in this case either Civic or a CRV. Then a year, 1999 and 2003, engine types. And we tried this, but the problem is, because the way Algolia is written, and the reason why it's fast, we eventually found out, is because it doesn't support nested and/or queries. So we couldn't do, give me Honda and Civic, or Honda and CRV. That wasn't possible because of technology. So we had to find another way. The other reason was some combinations do not exist. So we could make every permutation available from these data points. But for example, a 2001 Honda S2000 does not exist, or a Honda Civic 1993 with a 1.6 liter engine doesn't exist either. So that became a problem. So we cheated a little bit. Actually, we felt it was like cheating, but apparently Algolia does this all the time. It's a thing we saw in one of the presentations before as well. It's the level 1, level 0, level 2, level 3 way to build up stuff. So we built up a level 1 search engine, which is the make query clause. And then we had the level 1, which is the make and model, and the level 2, that is the make, the model, and the type, year, sorry. And then the level 3, which is the make, model, year, and engine. So in Algolia, we eventually got this data, in which it first said it's for a Honda, then it's for a Honda Civic 3-door hatchback, and then it's for a Honda Civic 3-door hatchback from 2001 to 2003 and to 2000, etc. And then with all the engine types, so kind of exploded. This is the JavaScript implementation. This is where we added a widget through one of the hooks, the Algolia hook after instant search start hook. So that is triggered in JavaScript, and then we add a little bit HTML to it, and then we have some triggers set on it that will read out the input fields and then pass on the query to the Algolia search engine and give us a result. So this is, you'll see here, this is the search bar. It's a Honda S2000, 2004 to 2009 2.0 liter, and then it will filter all the product that will only fit that car, because otherwise you'll get a lot of cars. So let's see if I can. Oh, French keyboard. Nope. Wow. Okay. Got it. Thank you very much. Interior, let's get the seats. Oh, well, the seats are mostly universal, so let's get lighting. And so if I select a model here, let's say a CRV, and it will change. And it's so fast. It's so fast. Check it out. It's so fast. Wow. Oh man, I couldn't get over how fast it is. I'm from PHP, you know, so it's just, it's like, wow. I didn't know technology could be this fast. So that's great. So within 10 milliseconds, all products are filtered, and this means we're 10 times as fast as the competitors because they still run on PHP without Algolia. So we're very fast, which is nice, and our client was very happy. Our roadmap, keep working on the Algolia Magento 2 extension, which is great. Did I mention Jan Petter? He built it. He's awesome. We do a lot of PRs for it and fix it with him, and he's really nice. It's great. And we wanted to refactor the part finder to React because we found out state management in jQuery is hell, and you know all the cool kids do React. We did PHP. So we want to be cool as well. So React. Thanks.
Do we have questions for Peters? Are you on beer? This is it? Question.
Hey there, I have a question which might be a little bit more for Guido, but I was just wondering how you implemented the main bar. Is that a custom hierarchical menu, or is it something else?
Yeah, it's just a field with drop-downs, selects.
Okay.
See, the data is not hydrated from Algolia. It's hard-coded in the jQuery
It's hard-coded
code.
JSON object.
Because we only have to update it when Honda releases a new car, which isn't that often. It's not BMW. So.
Well, if you're interested, you could actually make this with a custom hierarchical menu. I can explain it afterwards if you want to.
Nice.
Somebody else have a question?
Come find me and give me a beer, and then I'll answer more questions, also not tech related.
Thanks
Okay.
a lot, Peter.
Thank you very much.